Hello and welcome to the latest edition of WoodChat. I'm Sam.
And I'm Georgia, your new co-host. It is a pleasure to be here. I'm really excited actually to learn about some of the incredible innovations that are happening in the world of forestry.
Welcome on board. It's great to have you here. In today's episode, we're going to be looking at how a technology known as 3D printing could be harnessed to support construction in ways that conventional technologies cannot.
Yeah, that's right. Researchers are exploring ways of advancing 3D printing to build construction elements that are increasingly complex and strong and aesthetically pleasing.
But where does wood factor into the equation? Well, one research project currently being conducted at the University of Sydney in partnership with Forest and Wood Products Australia is looking at taking timber waste products such as sawdust and lignin combined with recycled plastic composites. The result? A high-performance construction material created using a 3D printer with an end product made entirely from components that would otherwise have simply gone to waste.
It's essentially upcycling, but on a much larger scale. As you can imagine, if this technology proves to be successful, the benefits to both the construction and forestry industries could be many and varied. Imagine being able to build entire buildings or even entire cities by using this process.
But just how realistic is it? Where are we at right now? And what are the hopes for the future? We spoke to Associate Professor Sandra Löschke, Director of Architecture, Design and Technology at the University of Sydney, to find out more.
Would I be able to ask you just to tell us a bit about your own background?
So many of my publications look into new materials, how they've been developed, how architects were actually at the forefront of experimenting with them or providing input into their development, and how they have been marketed. So there's these sort of technical aspects, but also the kind of more emotive and aesthetic aspects coming together.
And so what led you to this project?
I have a really long-standing interest in materials, but I also have a long-standing interest in advanced technologies. So the interest in this project was really coming from 3D printing and the larger question of what 3D printing would actually allow us to do that conventional technologies don't let us do.
You're able just to explain the concept of 3D printing?
So it's very much similar to a normal kind of extrusion process where you have a nozzle, you feed material into it, it is being heated and then it is being applied to a surface and then it hardens and you build up the object layer by layer. Often 3D printing is used to mimic other construction processes. We've seen it used for concrete, where concrete walls are built up layer by layer, but there's still a traditional reinforcement bars and steel that needs to be added. I was really more interested in seeing what the 3D printing in itself could give us that doesn't rely on traditional construction techniques, but gives us new ways of designing on building elements.
Could you give us an overview of what this project is all about?
So this project has two very distinct parts that are interrelated. One of them is really looking at technology. How can we actually advance 3D printing to build an element that is geometrically complex, but also quite strong and aesthetically pleasing? We are looking at timber plastic composites, so how recycled plastics and timber waste can come together to build a high-performance material. And we are particularly interested in how 3D printing allows us to grade a material. That means that how it can actually be fluidly varied, so how we can change the composition of the material within.
And to what end?
So if we think of a traditional external wall element, it would be usually a combination of very, very different systems that all have very different performances and function within that wall. So it's a kind of mechanical layering of different material systems. For example, it would be an external layer that would be for weather protection, it would be battens for a cavity, it would have a membrane for moisture insulation, and it would have rock wool or something for insulation, and then a finishing layer for aesthetics. So there are quite a number of different things coming together, being mechanically fixed, having interfaces. 3D printing can eliminate all this. If you can actually vary the composition of the material to be, for example, more weather resistant on the outside, to be more porous on the inside, to take on acoustic and insulating functions. You could actually do everything that all these systems do with all these different materials in one step by just changing the composition.
What was the prompter for undertaking this research?
The construction industry in particular, and this is my personal interest, it's basically very much lagging behind other industries. Much of labor is still being done manual. There's very limited use of prefabrication. And other industries are way ahead. For example, 3D printing is already used in the automotive industry, where smaller parts are 3D printed. So it is already beginning to be taken up elsewhere, but not in construction. So I think that's a really big opportunity to improve the quality of building elements, but also to reduce the amount of skilled labor that is actually required for building.
Is it happening elsewhere in the world, or are we leading the way?
It is happening elsewhere in the world. I think we are probably part of a group of people who are leading the way in terms of using timber. Most of the advances in 3D printing have occurred in concrete and other materials, but timber really is kind of lagging behind. So the idea of working with different timber composites, testing different timber species to make a new material from what is in essence waste, that's a fairly new idea.
Could you give me some examples of those waste products that are being put to use?
Yeah, so for our 3D printing elements, we've used mainly sawdust from Australian species, so red gum, grey box, but we've also tried more popular species that are used globally, like pine, and we've used ABS plastics. So plastics, particularly in Australia, is a big issue. We are meant to recycle them, but we're largely storing them, and most of them don't actually go back into the product chain. So 3D printing offers fantastic opportunities for making good use of these materials and actually valorizing them. So we're actually upcycling them.
So there's a definite environmental benefit then?
There's an enormous environmental benefit in terms of using very little more resources, but there's also an enormous benefit on the other hand, end of the life chain. So end-of-life management is particularly good for 3D printed elements. We have used our elements and reground them and reprinted them, and we found that they actually don't lose performance. So it's an amazing advantage for a product that you can actually have a closed loop to lead directly from end of life back into the production chain.
And so what's the process then? Would you be able to sort of walk us through how you get to the point of having that product?
So it basically starts with obtaining the materials. So we use sawdust that we get regularly from sawmills. We grind it down to the sizes we want, and then we sieve them. So we've been working with different particle sizes, which we achieve through different kind of sieving processes. And then we mix them with plastic pellets, so ABS plastics, and we create what is called a filament. So basically we filter the materials, we heat them, and we extrude something that is, you can almost imagine it like a yarn or a thread made out of the wood plastic composite. And it's this thread that then gets fed back into the printer head, where it's heated again, and then it's applied to a surface layer by layer. So it's the heat and the chemical reaction between the elements that actually creates the product. And I should mention that it also requires a very small percentage of binder. So it's called maleic anhydride is what we're using, and that helps the binding action between the plastic and the timber.
And what are the benefits then to industry?
I think it's the one-step process, which is really quite amazing, whereas other processes still require multiple steps. For example, pretty much most additive processes where you have a material, you saw it, you cut it, you assemble it, you mechanically fix it, and then you have a finishing step in terms of polishing as well. All these steps become unnecessary. So in 3D printing you have one step, but it's also of course saving labor and time.
Can it be done sort of on site? So are you reducing the need to kind of transport materials?
It can be done on site. It can also be done with local materials. That's why it's actually interesting to try different kinds of species. So theoretically, sawdust or timber particles are available in most sites across Australia. I mean, the ultimate dream for 3D printing is really just to print entire buildings, or people even dream of entire cities. You can almost imagine you have a portable printer and it just moves around the perimeter of a building and builds up the walls.
How far off is the reality of that?
It's not that far off. So in China, using concrete, they have already started to do this. But I think, again, what is holding us back is the way that we think about it still. So with concrete, we still mimic traditional construction. We still need to insert in reinforcement bars. So it's really of finding a way of how you can use the process to do things in a different way.
What have been the main findings or outcomes of your work to date?
So the main findings have been, there have been a number. So one of them is definitely to produce an element that actually is close to natural timber. So on one hand, we've been trying to increase the timber percentage in the composite, and we have been able to go up to 40%. With the material still being printable. We have also tried to replace the maleic anhydride, which is a chemical, with lignin, which is a natural timber waste product again. And we've also been very successful with this. The other thing is to actually make it look like a timber element and to make it feel like timber, so it actually could be a more marketable product. To help this, we've developed a printing process that actually allows for the variation in color and appearance with a pattern that is fairly much wood-like. But we've also developed a process that allows us to create a texture, a very raw or natural texture that also gives it a kind of feel of timber and these kinds of tactile terms.
Is it that you're kind of looking at two things then? You're basically looking at functionality and also aesthetic. Are they kind of two separate aspects that you're kind of been researching?
They're kind of coming together in many ways, because of course it needs to be functional, but it's no good having a functional product if it's unattractive and not marketable. I think that's a big problem for many new products. They might not be appealing, and if you can't actually market them or sell them, it will just stay on a shelf. But in this case, because it's one material, functionality and aesthetics are actually really closely intertwined. So we actually achieve the color by a slower printing process and by increasing the temperature. So it's actually a slight charring of the material that creates the pattern. But we also, of course, had to mechanically test it because it changes the composition, but the performance structurally is the same. So appearance and material and aesthetics is all very closely interrelated.
And so when it comes to that look and feel side of things, why is that so important?
It's a very good question. I think consumer research has actually shown that one of the reasons why composites are not so popular is because they're associated with hard surfaces, they're associated with unnaturalness, and that seems to be a big driver in the market. So to be able to achieve something that appears to be natural, that is soft and pleasant to the touch, it seems to be quite important. I think these are probably perceptions that are deeply ingrained in the human mind, and they are probably hard to change. So it's probably easier to actually produce something that corresponds to these consumer perceptions.
We've spoken quite a bit about the benefits to the construction industry of this kind of product and technology. I was interested to know what you would foresee the benefits as being for the forestry industry.
I think for the forestry industry, it's really the capacity to make use of waste materials. These materials are there anyway. It's not just sawdust, but it's also smaller offcuts that could be ground and reused. And it's actually part of a larger development that has already taken place, from solid timber beams to engineered timber beams. It's, the tendency has been to use smaller cut-offs and particles in a way that they haven't been used before. So ultimately this is the kind of final step in just using sawdust, which is literally the waste, to create a high-performance product.
Where are we now in the process and what are the next steps?
I think we're not far off to actually having this one adopted by industry. It just takes some conviction. I think it takes some will for the future from the Australian construction industry in particular, and probably some will to invest into research and development of new products.
Are there kind of preconceptions or preconceived ideas that you're trying to overcome?
I think there are always barriers to the market in terms of it's something that hasn't been tried and tested yet. There's always a risk associated with introducing new fabrication technologies and new materials. So I think it's maybe a little bit more enhanced in Australia, where there's less willingness to invest in research and development of new products. But that is not to say that this can't change.
Sandra suggested speaking to Paul Kramer of XLAM, a leading provider of sustainable building solutions throughout New Zealand, Australia and beyond.
Paul sits on the Micro Timber Research Project Steering Committee and, given his vast experience, we were keen to get his thoughts on what this could mean for the future of the construction industry. Hi Paul, and thanks for agreeing to chat to us today. Could you give me some detail about what your involvement's been to date with the steering committee?
I guess my involvement was around that pragmatic, practical assessment of the project and what might be the utility of the research beyond just being a basic research project.
And in terms of this particular research, what would you see as the main potential advantages for the construction industry?
Yeah, so there's a number of things I was challenged to do, and that was to try and come up with what applications might the project look at beyond testing it from a theoretical and then a pragmatic or practical perspective. Yep. And the sort of domains that I thought might be useful would be in the design of products for specific applications, and I'll go into those. The first one was where you've got very difficult or hard to get in places in construction, and so the creation of more intricate internal ceiling